Hello, welcome to my channel and welcome to my website. My name is Daryl and this is Programming in Any Language. The website is www.black-duck.com. It's where you'll find all my videos organized in logical order. Two-dimensional arrays are nothing more than spreadsheets. Yep, the one-dimensional array is either a row or a column. The two-dimensional array is both rows and columns. They are just as easy to use as a one-dimensional array. Initially, however, they can be a little confusing because it takes a set of nested loops to access all the content. Over 20 years ago, I was still consulting, but I was also teaching. I was teaching a course in Advanced Visual Basic, talk about programming in any language. One of the things I had my students do was set up the game Wheel of Fortune. Anyone familiar with the game will recognize that the puzzle to solve was a series of letters in 4 rows. Essentially, this was an array. Rather than me explaining it, I can show you this old program from over 20 years ago. The darn thing still runs. Take a look. Okay, what are you looking at right here? You're looking at basically something that's over 20 years old. It's something I did back when I was still consulting and I was also teaching at the same time. This is done in Visual Basic, and it's the Wheel of Fortune game. And as you can see, there's even a wheel on here that you can actually, well, you can't see there's a game board, turn on the wheel, there's the wheel. It does spin. Not that that's all that exciting. Makes some noise too. I don't know if that's picking up or not. Looks like it is picking up the sounds. Yeah, it is okay. That's enough of the wheel. What I do want to show you is the game board itself. And the thing I want to show you on top is this green piece right here in Wheel of Fortune. In fact, we can fill the array, and you can see it takes 2 to tango pops in there. What's it doing there? What's it actually? I can do another one. Remember the Alamo showing up here. Another one, Twinkle Twinkle Little Star, showing up in little squares here. What you're looking at is a two-dimensional array, and that's what this is all about here. We're not going to do this program. We may do this down the road in C# where it'll look much better. It's kind of 20 years is kind of showing a little rust right now, but this is a two-dimensional array that does work. There's even some object-oriented stuff down here too. We can have a keyboard that can click on things. You can actually pick out letters and you can move that keyboard around. You can even have Vanna move across the screen and turn the letters for you. This is something I did in an Advanced Visual Basic class years ago. So it's not done in C#. It's done in Visual Basic under Visual Studio, but again, over 20 years ago. So it's a little bit dated in what it can be, what it's doing. But the thing is, it's an array, and that's what we're going to be talking about now. If you look at a two-dimensional array, it looks something like this. It looks like a spreadsheet. It has rows and columns. It's not all that different from a one-dimensional array, except you've got 2 indices. Where we had a one-dimensional array, we would be going from 0 on down. It starts at 1 because it's a spreadsheet. And we look at this just one column here, basically, or one row, or whatever you want to call it at the time. We're now expanding that. We're looking at A, B, C, D here. You've done this before, back in the days when you were a kid, or something. Maybe now you still play the game of Battleship. You're using an array here. As you can see, we've got the 1, 2, 3 for 10, and we've got A, B, C, just like a spreadsheet where you're putting your ships and you're guessing where the other players are and doing that. In fact, back when my playground days, Battleship was actually a game we played on graph paper. We used something like this, where my ships were here, the opponent's ships were here, and we used an array, A through J and 1 through 10. We didn't start with 0. We start with 1 and we start with A when we did this kind of thing. With the computer now, we're using 0 as our starting point. We have to remember that piece when we get into this. But that's really what an array is. It's not all that different from a one-dimensional. If you look at it in comparison to what we can do with it, looking at one-dimensional arrays on the side here, we've got a first name and a last name set of arrays. We've got a string first name with 10 elements, string last name with 10 elements. We've got Daffy and Duck in here. So we've got all the first names in here and got all the last names in here. And if you look at the indices of 0, we can look at str first name 0 and str last name 0 and get Daffy Duck and put it someplace, stick it on a label or whatever we want to do. Same thing with Elmer Fudd, Tweety Bird. The indices are always the same for these particular things. Works out fine. We certainly do a lot with it. But if we look at a two-dimensional array, we can create one thing called str full name and take the pieces of the full name and place them in columns. I'm getting to columns here because you're thinking spreadsheets, databases, things like that. We can have, basically what we have here is rows and columns. We start looking at this. And we can get at Daffy Duck get at the Daffy piece by looking at 0, 0 and 0, 1 for the duck piece on here. So STR full name is represented with two indices, a row and a column indices. So we're looking at one piece of this at any time. So STR full name 10.2 is, so we're looking at basically pig by 10.2, looking at it like that. So let's dig in a little bit deeper and see what this kind of looks like. A two-dimensional array is like several arrays put together. It can hold and store multiple sets of data. It can be illustrated by a table with rows and columns. Rows horizontal, columns vertical. Rows and columns are numbered 0 through 1, 2, 3, and so on. You can see it right here, 0, 1, 2, and columns 0, 1, 2, 3, 4. Don't get too wrapped up on the row column thing. Authors tend to use row and columns because it sits well for our visibility. You can basically think of rows first, columns second, but it doesn't have to be. If you switch them, that's okay as long as you're consistent. But let's keep it simple. Let's think of rows and columns just to keep ourselves on track here. So how do we do this? A 2D array requires two size declarators, two indices. The first for rows and the second for columns. So we're setting up a rows is equal to 3 and a columns equal to 4. So this is defining what it's going to look like. And then we use something called double bracket, comma, bracket. The comma inside here tells us it's a two-dimensional array. And we're calling it scores, just like we call a single-dimensional array. We're calling it something. We say new doubles, rows, and columns. So we're putting a 3 in here, and a 4. We're saying 3 rows, 4 columns. We're actually creating that grid in memory. Does it look like a grid in memory? Who knows and who cares? We don't care how the system is storing it. But in our minds, it is rows and columns, and that's how we can work with it, because we'll be using loops to actually process this data. This declares that the scores variable references a 2D array. 3 defines the size of the rows, and 4 defines the size of the columns. The size decorator is separated by that comma, as you can see right up in here. So we've got rows 0, 1, and 2, columns 0, 1, 2, and 3. And it looks like this. At least we can visualize like this in memory. There's our columns, numbers 0, 1, 2, 3, rows 0, 1, 2, and our scores 0, 0. That's this element right here is referred to by scores with both elements in there. Scores 0, 1 is this one. Scores 0, 2 is this one. Scores 2, 3 is this one down here. We can access elements in a 2D array this way. Each element 2D array has two subscripts, one for its row and for its columns. Element rows are 0, 0, 0, 0, 1, 0, 2, 0, 3, just like I showed you before. Row 1 is 1, 0, 1, 1, 1, 2, 1, 3. Having the two of them, it can be a little confusing, I think, but if you sit down and just play with it a little bit, you'll be fine with it. Again, it looks like this. 0, 0, 0, 1, 0, 2. So you're thinking of it just like a spreadsheet. Where is 0, 0? Well, it's right here. Where is 1, 0? 1, 0 is right here. Where's 1, 3? It's over here in this particular thing. That's really all you're dealing with there. You can assign elements to the array. For example, score 0, 0 is equal to 71. You're putting a 71 right into the 0, 0's column. Score 0, 1 is equal to 67. So score row 0, column 1 is 67. We put it right in here. So that's how you can actually put things in there. Score is 2, 3. 2, 3. 61. We're putting a 61 in there. And that's exactly what we're doing. So it's very easy to work with. You can even assign it implicitly. I don't do this too much, but you may want to if you're setting a series of zip codes or prices or something like that. You could actually do this. Notice the braces. The braces on the outside are covering the array itself, and then the inside ones here are the rows. So we got 71, 67, 45, and 82 are all inside their own set of braces. So is this row, so is this row. If you look down below, they're sitting just like that. So if you set int brace, comma, brace, scores, and apply it like this, you're automatically setting up an array, a two-dimensional array, with 3 rows and 4 columns. Use nested loops to process the 2D array. This is where it gets confusing, I think, because you got to stop and think about this a bit, because you're going through each row at a time. I'm going to back up one here, and if we look at the previous column, if we want to look at this, we want to look at this one, this one, this one, this one, then increase the row to this one, then go through this, the y, increase x to this one, then y, and go through the process like that. And you can see it here. We're setting up an array with 3 rows, 4 columns. The int is going to be new rows and columns. We're going to set up, we're using a random number generator then to populate it. And we're using int row 0, while rows is less than rows, and row plus plus. We're going to increment it. And then we use the inside loop. for in column equals 0, columns equal cols, column plus plus, and then we say, finally we say our score, row comma column is random number generator 100. This, that simple. And we apply it like that. We can do the same thing when we try to add it to a list box. We can set up the rows and columns, and then we can take the scores, set it up as an integer with the rows and columns here. We're going to set up a two-dimensional array. Scores equal new int rows and columns. It's all set up. And then for rows, int 0, rows less than rows, row plus plus. In other words, we're going through, starting with 0. We're not exceeding 3, and we're increasing the row count as we go along. Remember, lowercase, these are different variables. Then we do the y, and we finally say list box item adds score rows columns to string, and that's the extent of it. That's all we have to do. Let's take a look at this in action a little bit. Let's go ahead and build a Visual Studio program. Let's create a brand new project. We're going to do it in C#. We're going to call it two-dimension demo. And we're going to put it out in my folder that I've got set up for this particular video. Where do I have it? I have it someplace around here. In arrays, two-dimensional arrays. There's a sandbox right there. Okay, cool. This sandbox right here will do just fine. Let's go ahead and select that folder and create it. We're going to create a very simple program right here. Let's get our toolbox out. And we can actually do this in form load, I think, initially. So we're going to go ahead and let's make this a little smaller. And let's go ahead and double click on the form itself and bring up our code window. We've got our form load object right here. I want to do a couple things. I want to put some things into the global area and then some things down here in form load. So let's go ahead and up in our global area and actually set up our const. We'll use constants here. Int rows equal 3, just like the example showed us. And we'll go ahead and say rows equal 3. Const int cols equals 4. Cols equal 4. And then we're going to set up our array. Int, set up our bracket, comma, brace, or bracket I should say. We're going to call it scores just like they did. Let's call it int scores. Set it up like that, and equal to new int rows, comma, col. And this will be set up array. And since it's all set up there now, we can go ahead down here and set up a new random number generator into our form load, so it actually does this right away. So we'll set up random. Rn is fine, equals new random, and that set up random generator. And then we're going to go ahead and create our loop. Let's get rid of the toolbox. We don't need it right now, so we'll get our code out here. We're going to say for int, we can use I equals 0, I is less than rows, and I plus plus. So we're incrementing rows each time. So that's going to be one of our loops here. So that sets up our count to be able to count through the rows that we've got in there. Well, we're on the first row. We want to stay on the first row and process what's in the columns there. So we're going to set up a for, and we're going to set up a int j equals 0, j cols, j, and then set up this set of braces. So we're setting up a dual loop here. It's going to go through I, and while I is 0, it's going to go through this thing until it reaches the max on columns, which is 0, 1, 2, 3. When it's 4, it'll stop. So right in this point in time, we can say our score, our array here, int scores ij is equal to random next. And we could say 100 in this thing. So we generate a number between 1 and 100. Gen a number between from 0 through 99 by saying 100 there. So that'll give us that. That's going to put it in place. And this is all we need to do. This is enough to actually populate that array. We can go ahead and save this thing and run it. And there's a pretty pitiful example of a program that ran and shows nothing, but it's got the array sitting out there. We can kind of prove that by going out into here and setting up a breakpoint and watching it actually do its thing. So if we do that like this right now and kind of do this, as soon as we start the program, it stops dead. And we can use the generator then to go ahead and hit F11 to actually step through this thing. And we can look at rows. We can look at our I. Let's look at I instead and set up a watch on this. And set up a watch on J. Add watch right here. We've got the 2 sitting right in it. It's not seeing that yet because it hasn't done anything with it. Our rows and columns we can go ahead and identify as well. We can add a watch to that and add a watch to the columns. And they're sitting up here, what their values are right now. And we'll go ahead and press F11. So we're stepping through this thing and we're going up, we're going through the columns. So 0, 0 is sitting up there. And we just put in the first element. If we want to look at the array settings, you can see that a 10 was placed in 0, 0. Nothing else is placed in 0, 1. We'll be going through that process now. So we'll go ahead and press F11. It goes through the J loop over and over and over again. Probably one more here. And now we'll take a look at it and see where we are. And you can see we've got the entire top row has now been filled with 10, 15, 28, and 18. If we could continue now, it jumps up, finds out that J has reached its max, so it goes up and increases I, which it does right now. It's now a 1, as you can see up here. It now goes through that process, goes through the J's all over again. The first one it puts in is a 41 into 1, 0. And then he does the rest of the process as we go along. I'll press F5 just to continue this thing on, and it's done now, and it completes its run. And it's all set. So that's all it takes to do that. To actually see this now, oops, don't want to do a breakpoint there. I want to get this out of here and do file save. What I'd like to do now is go to the form and do 2 things. Let's go ahead and get our toolbox out there. And our toolbox, we're going to go ahead and create a list box and put it over here. And we'll just drag it down like this. I'm not going to put an exit button on this thing or anything. I'm just going to keep it simple. And we're going to put a button on here. So here's our button. We'll put that button right over here. I'm going to go ahead and work with the properties of this thing. I do like my buttons to look a little bit larger than this. I'm going to say it's bold and it's a 10 and it's going to say do it. Okay, and then do it looks pretty good. I'll make it a little larger so it just kind of stands out there. And I'm going to take my list box and I'm also going to change the font on it and make it bold, make the size a 10. What I'm going to do now is I want to write code in here to go ahead and read that array that we just created and place all the elements in the list box down the side so we can actually see it here. So with that in mind, I want to change this button to button do it, BTN do it. And list box I want to say, we'll say LBX out, LBX OUT, so we have it there. So we have names and code now. I'm now going to go ahead and double click on my do it button and get at that code we've got here. So our code window pops up like this. We can actually use the same thing we've got here. In fact, I'm going to actually steal this code. All I want to do here is basically take this and use that same looping structure, but instead of this piece, let's get rid of our toolbox. Instead of placing it here, I want to actually go ahead and create my list box here. So I'm going to go ahead and get rid of this line of code, and instead I'm going to say that our LBX out dot items dot add is equal scores ij, and this will populate list box, and that's all we need to do. So basically the same looping structure goes through this process and we actually created there. Is this thing going to work? Sure, it's going to work. Save all, start. There's our program. Where's it coming up? There it is. There's our program. We know it's created the array already. We checked that with our debugger before to see if it's actually working. So we got stuff out in the array. So now we're going to put it in here. We just click the do it button, and bang, it's sitting there. So 54, 87, 14, 34, 94, 0, 91, 89, 82, 27, 92 are our rows. Are the 3 rows that we've got in there. So we actually grab this up and we actually popped it in there. If we want to see that thing split up again, I think we can do this. Let's see, 4x, blah, blah, blah. Let's see, we can say that after it's done the J thing, I think we can go actually right in here, right after the for loop. Can we do it right after this? I think we can. Right after this, we can say that LBX out dot items dot add is equal to, let's just say new row, next row. Let's just leave a space. Just put a spacer there. That may be enough. Space between rows. Now, if I'm right on this, oh, we've got LBX items to add. We got a problem here. Let's see, LBX items to add. Oh, I'd say I did wrong. Yeah, I need to go like this. Put a parentheses around it, then the quote space quote, and do it like that. That takes care of it. Yeah, you got to have it in. Oops, no more of those parentheses there. Now we're in good shape. Now it's good. Okay, yeah. What am I thinking? And up we go. And run it again. Do it. We got our spacing in between it, so you can see our rows actually sitting there. So that's really all it is. We're basically assigning values to this thing using we use the list box to do it when we actually did it, but we actually placed them into the pieces in this array. So two-dimensional arrays are very easy to use once you understand the way you handle the indices. We'll look next time. We'll throw basically a tic-tac-toe simulator together where we can use an array and process through this. You'll see that. That's two-dimensional arrays. There are definitely advantages to using two-dimensional arrays, and they are essentially what a data set is when you work with databases. They're useful for a wide range of data, such as graphs, maps, and tables. They're also commonly used in image processing and game development. Expect to see 2D arrays in many of our upcoming videos. They are super useful. I'll see you next time. Thanks for watching. Don't forget to use the website for easy access to all my videos. And if you get a chance, please subscribe. That way, you'll be notified when something new is available. We'll see you in the next video. Take care.